Let's look at MATLAB's rounding of numbers. The four commands round, ceil, floor, and fix do the rounding of numbers in MATLAB. They do this rounding through different approaches or different methods. The round command rounds towards nearest integer. The ceil command rounds towards plus infinity. The floor command rounds towards minus infinity. And the fix command rounds towards 0. These four commands are applied to the x vector, which is a linearly spaced vector in minus 10 to 10 with 100 points. So let's look at the graph of the round command. Round applied to this x vector. If you look at the neighborhood of 4, the round command rounds towards nearest integer. So the integers, the rounding of numbers from minus 3.5 to 4.5 should be 4. So look at the neighborhood of 4. So minus 3.5 to 4.5 all map to 4. 4.5 to 5.5 map to 5 and so on. So this is how the graph of the round command looks like. Now let's look at the graph of the ceil command. Ceil rounds towards plus infinity, and this is how the graph of the ceil command looks like. So the x vector is kept same for all of the four commands to see comparatively how the rounding off is happening. The floor command rounds towards minus infinity. So this is the graph of floor command for the same x vector. And the fix command rounds towards 0. So this is how the graph of fix command looks like. Now comparatively, if we see, the round and ceil are together plotted in this graph for the same x vector. So round rounds the number to the nearest integer, ceil rounds towards plus infinity. So this is how the graph looks like for the same x vector, comparatively seen here. The floor and fix commands respectively do the rounding off towards minus infinity and towards 0. So the difference is now visible from the comparative graph between the floor and fix commands for numbers from 0 to infinity and 0 to minus infinity. So the difference is clearly seen from the graph for these subsets of the real line. Fix fixes towards 0. So floor rounds towards minus infinity. Now often while designing algorithms in which the rounding of numbers can play a part, can influence the result, we come across such functions. These functions need to be evaluated to see the influence of the rounding of numbers on the performance of algorithms. So here we plot ceil x minus floor 1 minus x. Normally we look for one of the objects we look for is the zero crossings. So the points where these two functions are equal, ceil x equals floor 1 minus x. So this particular function plotted on this graph for the same x vector has no zero crossings. So the ellipse, it's highlighted. It's highlighting the part which is closest to the x-axis. So there is no zero crossing for this curve. So there is no x for which ceil x equals floor 1 minus x. If I see the function sine of ceil of x minus floor 1 minus x, then this is how the graph looks like. This function also has no zero crossing. Now the function we plot is ceil x minus floor 1 minus x squared. This function does hit 0, and the solution is highlighted here through the ellipse. So those are the points, those are the abscissa values for which ceil of x equals floor 1 minus x squared. Another function, ceil of x minus fix of 1 minus x squared. So this has some solutions, as is evident from this graph. So the points which lie on the x-axis are the solutions. Or basically, they are the zero crossings of this curve. It's not actually crossing, but it's certainly touching the abscissa. So the points where this curve touches the abscissa are the solutions for this equation. Now, in this plot, we see comparatively how the four rounding of numbers influence. The round, ceil, floor, and fix are drawn in one plot to see comparatively how they do the rounding of numbers.